Hello, good morning, everyone. Thank you for inviting me to this very important symposium. So I'd like to share with you the Singapore's perspective on food waste reduction and also food circular economy and uh, sustainable packaging solution is one of these development. Okay, so when we talk about food security in Singapore, SG stands for Singapore. Um, we should look beyond the global security index. As you can see, based on the economics the magazine ranking, Singapore is ranked top in the world in terms of global food security. How could that be possible? But if we look deeper, and there are like every ranking, there is a set of ranking criteria. In the food security index ranking, we mainly look at the three criteria. One is affordability, the second one is availability, the last one is quality and safety. So for those colleagues and friends who have been to Singapore, you will know that the food is very much affordable. A lot of food around, so very much available too, and it's very safe because we have a very strong framework to ensure food safety. But if we look beyond this ranking criteria, what you see is actually the underlying risks. First one being the nature of the food the availability in Singapore. Singapore is a very small island state. We have the land area is about 700 kilometers square, much smaller than most cities in the US. And we import more than 90% of food from 180 countries. So this diversification of food source in peacetime should not have any problem to ensure the food availability. But the ongoing COVID-19 pandemic has shown us other way around, otherwise. So increasingly, we see the impact of this pandemic on the food supply chain, disruption of movement, and the supply chain of the goods, including food. And at the more general scale, we see the impact of climate change. This will affect the production level of traditional agriculture, which sooner or later will impact on the ability for Singapore to import food. So with this in mind, Singapore government has developed this new vision that is to achieve 30% of nutrition requirement from local production in about 10 years time, 2030. How much are we producing locally? Well, for the 700 square meter kilometer square of land space, 1% of land is allocated for agriculture. So the local production level right now is around 10%. So these are the challenges facing Singapore food security. We have a shrinking farmland to clear the land for urbanization and industrialization. So much so that this is a result of this drive towards industrialization and urbanization. So we have now less than 1% of farming land. The second challenge is the food waste. We generate too much food waste partly because food is so much abundant and so much affordable for the general public. So we don't really treasure the value of food. And as a result, undesirable result, we generate a lot of food waste. And the third one is the aging population. This is a very fast-paced country. People work very hard. They have not much time to date, to get married, and to have children. So as a result, the population is fast aging. So when we talk about food security, we look at these three elements, interconnected three elements. And how do we develop solutions? Well, primary production, urban farming, technology-driven farming practice is one that can help us increase local production yield, but not to the full self-reliance level. The food waste reduction is a key area that we need to address. For this, we can go by two approaches in opposite direction. First one is to develop natural food preservative to extend shelf life of food produce. Second one is to take nutrient out of food waste. This is where we can see the development of biodegradable packaging material in this space. I will skip due to time constraint, I will skip the nutrition part entirely for tonight. This is our food science and technology program. Basically, there are two areas. One is education for talent development. The other one is food circular economy. I'll focus on the research area. So basically, if we look at the food waste situation, we have two type of food waste. One is a homogeneous processing industry side streams, like soybean residue, for example. The other one is a heterogeneous household food waste. Reducing food waste is very important because we do not have animal farm, and we burn all the food waste for landfill. But there's a capacity issue, so developing technology innovation to reduce food waste is a key space for us to move in. We have used fermentation technology to recover nutrients from this food waste. In this case, soybean residue. You can see that fermented product can support urban farming. In this case, protein-rich microalgae can be sustained using our fermented product. But if we look at the soybean residue, 40% of it remain insoluble because they are high in fiber content. So if we do not remove this solid residue, we're not solving the problem entirely. Therefore, we have developed this cellulose extraction method to take the cellulose out of the remaining residue and to convert them into packaging film. And these are truly biodegradable. And another thing we need to take note is our versatile nature of our technology innovation. For example, the cellulose extraction method can be applied to all the other fiber-rich raw materials. And in this case, we see here is actually soybean residue, and this one is a tropical fruit called durian, the shell of the tropical fruit. We can apply the same technology to take cellulose out of it and then convert it into biodegradable packaging film. By doing so, we actually close a loop and to have achieved the goal of reducing food waste entirely. This is a term we call it zero waste food processing. Our innovation has caught attention from CNN. They have flew in from Atlanta, USA to film our innovation and push out in the program called Going Green, which is available on the CNN network in December 2019. So this is a sort of our technology platform. They're twofold. One is a fermentation, as I mentioned. These are the side streams from food processing industry, which includes soybean residue, spent green, the barley green that is used to make beer, and then the waste cooking oil. So our innovation allows nutrient recovery from these side streams, which can then be applied for various applications, including the urban farming of a microalgae. The remaining residue, we have developed a cellulose extraction method to convert them into packaging material. And also, we can extract the antimicrobial phenolic compound from these raw materials, and this can then be applied as either as a natural food preservative or even be part of this antimicrobial mask to prevent the spread of COVID-19 infection. This is a slide shows this image shows the green processing technology that we have developed to take food ingredient out of the raw materials without any organic solvent or chemicals. So this is a summary, and our biodegradable packaging project has brought us to a international competition finals organized by Singapore Temasek Foundation. So this is another summary slide to show that the green processing can be useful to sort of make the food source more sustainable. I already mentioned this urban farming using the fermented product. This is a tropical fruit called durian. The shell of it is very high in fiber. So we have extracted cellulose before converting into a biodegradable packaging material. And the seeds of this tropical fruit can also be converted into a food stabilizer and emulsifier. This is the same slide you see. It is the same image related to the competition, international competition. In this case, our platform technology of fermentation allows the removal of minerals and protein from shrimp shells. And this will allow the enrichment of chitin, the conversion into chitosan, and then the making of a biodegradable and antimicrobial packaging film. And this is a sort of application of innovation. In working with the food industry and government agencies, we also make sure that our innovation are of high academic standing. So for this, we have published all our innovation in the top food science journals, including Journal of Agriculture and Food Chemistry, Journal of Functional Food, Food Chemistry, and the Scientific Report. And our innovation, in addition to CNN report, the Going Green, has attracted global media attention. That include the Bloomberg News and the AFP, Agence France Presse, BBC News, CNBC reporting, and even the Japanese media. This is my research group, which is entirely funded by food industry investment. So to summarize, our innovation has created this food circular economy, which actually is the aim is to maximize the food utilization. And the sustainable packaging solution is one of the development from this circular economy, as I mentioned earlier. The aim is to valorize food waste through our innovation, moving towards zero waste food processing. And in doing so, we are creating a future efficient food system more suitable for urban setting. And then together, we are also developing this food safety science and innovation, because when we reconnect back these nutrient recovered from food waste, when we introduce biodegradable packaging film into the market, we need to make sure they are safe for consumers. And by doing so, we actually cover all the aspect of food science and technology development, and produce a useful product, including food and packaging material for the consumers. Thank you for your attention. This is the end of my presentation.
Thank you, Professor Chen, for this very interesting presentation. Very intriguing what we can do with all these biomaterials. And we have this tremendous challenge to deal with plastics, right? And packaging seems to be a never-ending story of use and recycle. So I was wondering how close are these innovations to reach markets, or if any of these innovations are already being produced by a company in Singapore?
Very good question. Because of the reason is that we have attracted so much industry investment interest is mainly the simplicity of our technology, and therefore by simplicity is also linked to scalability. So why is it simple? Because we were forced to at beginning when we started this activity in the food space 5 to 6 years ago. University was asking me to lead the education partnership. So as a result, I was not supposed to do research, but as an academician, our hands are always itchy to do some research related to anything we see around us. In this case, we use very limited resources to develop simple innovations to solve a food problem of relevance to Singapore. And so, to answer your question, we have we have developed about 10 intellectual properties. Some of them have been licensed to industry, like the antimicrobial mask. For the packaging material, we are working with 3 companies to push them out on the market in the next 1 to 2 years.
Excellent. This is promising. I think there's more work in packaging is really necessary at this point with, again, this tremendous waste, not just in Singapore, everywhere around the world. And
yes.
we struggle to deal with this plastics issue we have. So we have another question from the audience, and this will be the last question, and then we'll move to the next speaker. So how long does the organic food wrap last, and or what causes it to break down?
Excellent question. When we talk about biodegradable property of these new packaging materials, there are 2 things we need to take note. First, is a paradigm shift from petrochemical-based packaging. We are now moving to food-based packaging material. So from food for food. Over time, I think these will be easier for consumer to accept because we don't have to worry about the leaching of chemicals from the packaging material to the food. To answer the question on the biodegradable nature of these packaging materials, they are stable at the room temperature or refrigerator condition, and they are also heat stable. In the normal condition, almost forever. When we talk about biodegradable, we are talking about when we bury them in the soil, when they are in contact with a microbe, they will be gone within a month. So we have tested this in the soil, and over time we have taken images of the degradation process. So within 3-4 weeks, they are gone. So this is perfectly for future packaging because we will not see this microplastic or general plastic waste in the ocean, in waterway, in the environment. Yep.
Excellent. So I think that's, I imagine that this is due to the effect of enzymatic action of microorganisms in the soil.
Exactly. Yep.
Excellent.
That's right. That's right.
So thank you, Professor Chen. This concludes your talk, and we'll move to the next speaker. Welcome again. We're going to start our second talk today. This is by Professor Haley Oliver. She's a professor at the Department of Food Science at Purdue University in West Lafayette, Indiana. It's a place very dear to me. It's my second alma mater. She received 2 bachelor's degrees because one wasn't good enough in microbiology and molecular biology from the University of Wyoming. She received her doctorate degree from Cornell University. Professor Oliver teaches food microbiology lectures and laboratories, food plant sanitation, and graduate food microbiology. Her areas of research include investigating foodborne pathogen transmission in retail food environments and the use of molecular methods to understand how foodborne pathogens survive stress and cause disease. Professor Oliver is the director of the Feed the Future Innovation Lab for Food Safety, which is one of our peer institutes as the Soybean Innovation Lab. This is a collaboration between Purdue University and Cornell University researchers that aims to enhance global agricultural sustainability and resilience, as well as food security. Her presentation today is titled Food Safety versus Food Quality and Their Interactions. The floor is yours, Professor Oliver. Thank you.
Thank you, Juan, and thank you to our host for the opportunity to present on food safety. It is something that is very important to me. I'm very passionate about it, and certainly would offer the support to any individuals out there that are interested in the Food Safety Lab, which I'll get into a little bit toward the end, more of what we do and the direction that we're headed. But I always appreciate the opportunity to talk about food safety versus food quality and how they overlap, but they truly are distinct things. So just kind of to set the stage, everybody loves a good definition. So food safety is really making foods that are safe to eat and they're free of disease-causing agents. And those can come in a number of forms, whether it's biological, chemical, or physical hazards. And we think of, at least we traditional food scientists, think of food quality as making a food that's desirable to eat. So taste, color, texture, and that could be in its native form, or that could be through modification through food processing. And so safety is really kind of health forward and quality, while nutrition can be embraced there as well. Really, we think of it often from our lens as something that's desirable to eat. And so they really are truly related. When I work with industry, certainly I have to emphasize, and with students as well, that if I have to weigh food safety versus quality, I have to put a little more weight on food safety. Because really at the end of the day, if a food can be extraordinarily high quality, but if it's unsafe, it's still not suitable for human or animal consumption. And so really when we think about food security as a whole, through my lens, it's foods that's nutritious, it's available to populations, and there's enough of it. And so under those 3 conditions, we typically feel that food security has been achieved. But we're trying to emphasize that food safety is really the 4th pillar of the discussion around food security, because if your food is not safe, it's not appropriate or not good for human or animal health and consumption, which means we no longer have food security. I think it was a really great presentation by Dr. Chen a bit ago that emphasized how we need to start to address the challenges of food loss and waste, and that packaging can play a really big role in that. While these data are a few years old, it does underscore how much food is being lost and wasted per capita by major regions of the world. And I always like to point out to my students here at Purdue University, look at North America. And what makes it slightly unique is that a lot of food loss and food waste it happens at the consumer level. And a lot of that waste is driven by perceptions of quality. We have pretty rigorous best buy and sell by dates and guidance for consumers in the US. Those are all benchmarks of quality. But a number of consumers, certainly members of my family still, think about those numbers or recommendations on food products as safety guidance. They're not safety guidance. And so why we see a larger percentage of foods that are thrown away at the consumer level in more developed economies like Europe and North America is because of perceptions that they're unsafe, even though they're probably safe and just trending more toward lower quality. When we look at per capita losses of oilseeds and pulses around the world, we see that Sub-Saharan Africa and North Africa really suffer a great deal of loss in these really important food crops. And because of processing and our vertical integrated systems in the US and certainly in Europe, we've been able to prevent some of that loss. But you'll see that post-harvest and at primary production is where the vast majority of losses occur globally. When we take the food quality and loss due to perceptions of quality, that's one side of the story. The other side of the story is the global burden of foodborne disease. And as we look at the World Health Organization's estimate of loss due to foodborne disease, you can see that Africa exceeds most of the world in that total burden. And while each one of those microbes listed below may not be something you think about all day, but it's certainly something that our research is trying to address. So looking at the challenges of foodborne illnesses such as salmonellosis, vibriosis, and diseases caused by a number of different E. coli really create a huge burden to human health around the world. And why there's such a focus on trying to improve food safety in Africa, as you can see, it's underscored the amount of individuals that suffer a foodborne illness and the long-term impacts that it has on their lives. Now, this is really focusing just on the enteric hazards or biological hazards. We have a resident expert in our next talk who can talk about chemical hazards such as mycotoxins. But again, Africa suffers a similar situation in that the 4 major chemical hazards that are actually biologically driven, so from molds, aflatoxins, for example, a significant burden to the African continent. And what we know about the biological hazards such as salmonella and chemical hazards such as aflatoxin is that these diseases are preventable. And while preventable, it takes a considerable investment in order to prevent those diseases. So food safety, there's a number of definitions really in the world of what it is, but the way we look at it is how do we make food that is safe to eat and free of disease-causing agents? And at the day, what that really means is that we have minimized or reduced the hazards in foods. So we've reduced the biological hazards such as salmonella. We've prevented chemical hazards. It's hard to remove a chemical, but we can prevent contamination, such as minimizing overuse of pesticides or prevention of aflatoxin production. And then something just as simple as physical hazards, which can be bone shards, puncture. So when we can achieve a reduction in the risks in each of these 3 hazards in foods, that's when we truly are beginning to reach our ultimate goal of food safety. And again, just to highlight a few examples of these types of hazards, chemical hazards can be sanitizers. So we could be trying to improve food safety through better hygiene in our environment, but actually create some risk if we have sanitizers that are inappropriate for the conditions or if they are at higher concentrations. And that would be applicable also to something like pesticides. Physical, as I mentioned, is a little more obvious. So as we think about even in the soybean context, making sure that we remove rocks and metal and other just naturally occurring physical hazards that come from harvest, making sure that those are sorted away to prevent something as simple as breaking a tooth. And boy, there is nothing more awful than breaking a tooth. And I would know, I spend a lot of energy trying to keep my teeth intact. So, and then really where my lab focuses and what the focus of the Food Safety Innovation Lab is really reducing biological hazards. There's been a tremendous investments that have been made in commodities across the world trying to reduce mycotoxins. And while some progress has been made, there's still a lot to do. But as you noticed in some of the previous slides, the total burden of foodborne disease is actually, the vast majority of it is actually biological hazards, which is why the Food Safety Innovation Lab really truly focuses on biological hazards. So again, just because something is high quality, so it looks, tastes good, it can even still be nutritious from maybe a vitamin profile. but it doesn't necessarily mean that it's safe. And then something that is safe does not necessarily mean it's high quality. So it could have been processed to a point where it's lost nutritional value, or it's no longer accepted by consumers for its texture or its taste. And so it's a fine line. We're trying to really achieve both of these things. And as we look at research for development in particular, we have to keep both food safety and quality in our lenses. And the question often comes up was, how do food safety and nutrition actually interact? Well, they do, and our innovation lab falls under the nutrition branch of the Bureau for Resilience and Food Security, because if you have someone who becomes ill with a foodborne disease, they can become malnourished because of lack of absorption of foods and critical vitamins and minerals from those foods because their intestinal epithelial is disturbed. And so that can lead to a feedback loop of then dissemination of more pathogens into the environment, more people becoming sick, and a really long-term reduced quality of life and long-term outcomes for individuals. So as we look, at least more specifically from a soybean lens, while I'm not a producer of soybean myself, I certainly know plenty of individuals engaged in soybeans, particularly here at Purdue University. So from the United States Department of Agriculture lens, soybeans have defined quality and identity standards. And yet tucked within these quality and identity standards are still some aspects of food safety. And it's not always maybe thought of that way, but they are there. So the first, just taking snapshots from USDA's quality standards, it defines, first of all, the two classes of soybeans, yellow versus mixed soybeans. This is simply quality and identity. There's no language in this particular guidance that talks to the idea of food safety. But it certainly does to quality and identity standards, which of course can have significant economic impacts. If we look at some of the other criteria, such as damage and foreign material, now not only are we getting into the space of identifying challenges with quality, but we're easing into some language here that could have implications for food safety. So anytime that we have soybeans that have a higher moisture content than we would hope for long-term storage, that's how we get maybe sprout damage or outgrowth of microbes that can produce aflatoxins. And so not only is it damaging the kernel, so we have a reduction in quality, we now have a food safety hazard. And of course, foreign materials falls under that physical hazard category, where if we're not able to sieve away things such as rocks or other foreign materials that might mimic at least the size of soybeans, we do have potential safety hazards there. Some of the other points of heat damage and stain similarly, where if the seeds themselves have experienced an environment that could result in this type of damage, it means that those seeds or beans may have been in an environment that could actually increase their risk of being a food safety challenge. And so collectively, when we look at the grades for standards, at least in the United States, for soybeans, and we look at damaged kernel and other materials and how it impacts grade, this is a really good example of how safety aspects and quality aspects actually intersect. And of course, this is one of my favorite pictures of great soybeans and some really challenging soybeans. And of course, coming up next, you have an expert in mycotoxins who can really talk to why we care about these particular food safety challenges. The long-term implications for human health and also for animal health are really quite significant. As Dr. Chen pointed out in his first talk, is that there is a significant amount of value that can come from food processing and packaging. So not only do we have an enhanced quality, we can preserve nutrition, but we can also enhance safety at the same time. And it's challenging, the word food processing, again, working in a food science department at a large agriculture university that's trying to really, one, maintain food security, but also think about the economics of them. Food processing is a challenging word to us because it in some aspects of the consumer groups, food processing means that it's fake, or it has somehow taken on characteristics where it's no longer food. Well, the definition of food processing is extremely wide. Bagged lettuce or chopped lettuce, anytime we purchase something like that, we have purchased a processed food. And yet we've done very, very little other than wash and cut up that lettuce. So another thing that the Food Safety Innovation Lab really promotes is food processing through the lens of food safety, certainly, but how it can enhance safety, enhance nutrition, and certainly long-term add value. You know, tofu processing is one example of improving the quality and nutritional value of a commodity such as soybeans, and how we can also enhance safety. And so what you'll see on the right is a classic flow diagram, so a processing flow diagram of how tofu is made. And when we take a look at how some of our soy-based products are made, we can highlight steps in those processes where nutrition is increased, but we can also identify some of the most sensitive times in this product's production where safety is either enhanced or can be compromised. So one example is heating our soy milk up to 180 degrees. Not only is that a part of the processing process to actually develop tofu, it's also an opportunity for us to reduce the microbial load, which could potentially include pathogens in this case. So food processing still has a very big place at the table as we try to look and improve food security internationally. One of the most important documents, at least in my opinion, that has been produced in the last few years is the Global Food Safety Partnership's assessment of food safety in Africa. And what this did is it was a meta-analysis of 518 projects, that represent 31 donors and over $300 million in either research or development efforts to try to improve food safety in Africa. And also 200 experts were interviewed to understand really what is the state of investment of food safety in Africa and what are the opportunities and needs looking forward. And so the major conclusions from this study is that the vast majority of investments were in commodities that were seeking higher value add, and yet the greatest burden of foodborne disease is actually from foods from informal markets. And so there's a disconnect between where people buy their foods and where investments being made. Furthermore, another big conclusion from the Global Food Safety Partnership meta-analysis was that the vast majority of food safety investments had focused on chemical hazards. And this is not to say that there are not chemical hazards. We saw from the World Health Organization data that aflatoxin exposure has a significant impact on human life, and particularly in Africa. However, if we take a step back and look at the microbial side, there are more daily average life years lost due to microbial hazards such as Salmonella and Campylobacter compared to aflatoxins. Both really big drivers, but from this data, it says that there's a need to increase the investment to look at microbial hazards. And then the final major gap in food safety, at least from this meta-analysis, was there's a need to invest in local and consumer-based awareness. There's one way to describe it as a push-pull model of how we enhance food safety. We can have government positions and industry that intentionally improve food safety through policy or through food processing, if we're talking about industry, and the consumer benefits. And so that's really a government or policy-driven approach, as opposed to the pull method, which is where maybe the consumer themselves demand safer food. And so we want to see an environment where consumers are more aware of food safety. They know what their risks are and that they can put more pressure on government, on industry to produce safer products. And so taken collectively, these three major conclusions from the Global Food Safety Partnership are really the drivers of the Food Safety Innovation Lab research portfolio. And because we have a few minutes, I'll mention a little bit about what we do and what we'll be doing in the future. But this is a partnership between Purdue and Cornell universities. And as you notice, those are two important universities to my past and to my presence for sure. But the motivation for having two universities in this is that we brought together what we felt were some of the leading experts in food safety in the world. and that Purdue and Cornell have different interests from a research standpoint and also from a commodities-based difference, that we needed both technical expertise. It's a $10 million USAID investment, and we have the opportunity for more research through associate awards and buy-ins as our project progresses. We envision this, and it is developing into a private sector, government, and consumer stakeholder partnership. And we need the government sector, we need the private sector, and we need enhanced consumer awareness in order for us to truly meet our goals of food safety. And our focus countries at this moment are Bangladesh, Cambodia, Kenya, and Senegal. I've kind of set the stage for why we do what we do, especially when we look at the World Health Organization data, but collectively 125,000 children die each year from foodborne illness. And when we take then an even bigger leap coming back to value add and what we can do with some major commodities like soybeans, unsafe foods do inhibit access to higher value markets. So you can produce a fine product, a high quality soybean, for example, but if it's unsafe, it has limited capacity to seek those higher value markets. We're also cautious in the Food Safety Innovation Lab when we think about technologies. A great question was asked by the audience, how ready are these technologies for use, or how close are they? We're very careful with those because we want to adopt or scale up practical, sustainable technologies. Just because you can sequence the genome of a salmonella from Kenya, the question remains of, is that important and does it save lives? So we're cautious and excited about technologies that truly enhance food safety. Of course, we did use the Global Food Safety Partnership to drive our 4 major themes of increasing awareness. We want to develop research capacities at local research institutions. We want to support policy. So our partners, as a part of the Innovation Lab, are working with local governments to rethink some policies or streamline food safety policies. It's not a big surprise that most countries have very complicated food safety jurisdictions, just like the United States, and that trying to really genuinely understand who's responsible for food safety, especially by commodity or food group, or whether it's processed or not, is actually really challenging. And of course, once we have a better understanding of policy, that's when training and developing local capacity can be really important. Another piece that of our lens that we really keep very forward is we want to make sure that each of our research for development projects are empowering women and youth. We know that women make the vast majority of food decisions for families, and that they're also big drivers of knowledge transfer. So if we have the ability to teach women or enhance their understanding of food safety, they will teach their children, and therefore we have a lifetime learning event. The other 2 cross-cutting themes that we really keep in focus are developing human and institutional capacity. We are trying to work ourselves out of a job as a part of USAID's path to self-reliance. We want in-country human and institutional capacity to take over roles in food safety. And that really ties into enabling environments, which is where we have government and industry buy-in for food safety. So this is our team. Again, I have the pleasure of being the director of the Food Safety Innovation Lab, and my counterpart, Randy Warobo at Cornell, is an absolute delight and an expert in vegetable and fruit processing. Molly Webb and Julie Hancock are the behind-the-scenes absolute machines that keep our innovation lab going. But as I mentioned, our strength comes from our technical experts that are represented both at Cornell and Purdue University, where we can cover everything from economics, produce, animal, and dairy systems. And that's important because each one of those has a major role in truly driving improvements in food safety. As I mentioned, these are the countries in which we work at this point in time. We do have some COVID-specific projects where we're holding COVID-based office hours for industry in each of these countries, but also Tanzania and Nepal. Of course, COVID-19 has had a massive impact on our food systems, and being able to help small to medium food industries navigate COVID and employee health to make sure we can maintain food security certainly falls within our wheelhouse in the Food Safety Innovation Lab. Just briefly noted here, these are the initial research investments that we made with the Innovation Lab, and we now have what soon to be fully announced long-term projects that are 3.5 years long in each of these countries. But the first thing that we did as an Innovation Lab was conduct a landscape analysis to understand the state of food safety, or at least an aspect of food safety in each of these countries, so we know how to best invest US taxpayer dollars and to support the in-country teams to truly reach their long-term goals of food safety. So again, it's an absolute honor to be the director of the Food Safety Lab. It's a position I take very seriously because we are entrusted to make research investments that actually drive improvements in food safety, and that can often be very difficult to measure. But I'm happy to take any questions about food safety and certainly about the Food Safety Innovation Lab. Thanks.
Thank you, Professor Oliver. This was a very nice presentation. Again, I have been in so many places around the world at this point, and the people keep confusing safety and quality, which is it's a striking thing because I haven't heard of a piece of very good quality protein actually causing you diarrhea, but it's the case. It's the case. I want to ask you a couple of questions, and we'll save the rest of the questions for the panel at the end of the presentations. These push-pull model, which has been out there now for quite a few years, do you think this building this consumer awareness in places such as Bangladesh have been there? The Food Safety Authority, I would call it brand new. Do you think this push-pull model could lead to significant effects, at least to create this awareness among the population, the consumers seeking these safer products?
Yeah, Juan, that's a great question. And you're right, the status of food safety and the Bangladesh Food Safety Authority really are quite new, so quite young in Bangladesh. And so it is I guess we could view it as an interesting case study of how the push-pull model actually may work. There are increased efforts through some of our sister programs that are USAID funded to increase specifically awareness. So it's really well recognized that driving consumer demand and awareness and that repeated discussion of differentiating quality and safety is a big part of actually driving accountability to food safety. You know, when we think about food safety, it isn't free. There are investments that come and needs, input needs that are required to improve food safety. But if there isn't a demand or if there's a lack of awareness, the motivation to do that is really quite low. And so because the Bangladesh Food Safety Authority has been established, there's recognition from the top, from the government structure, that there's a need for policy and structure. Now there's a need for implementation and maybe simplification. It's a really challenging policy and I think there's 23 or 27 different sectors of the government that are actually involved in food safety there. And so getting that organized to actually implement food safety is a challenge, because then that has to be sent out into the field or implemented in the field with the processing and production sector. So it takes all three, really. It's like push-pull and then like a bow in the middle, I guess, to get all three of the major stakeholders to the table to be, really toward food safety.
Thank you. Thank you. I think the next question is about innovations. And I wonder if, what's the type of innovation that we need in food safety for low, middle-sized companies, which are the ones populating the new companies, the new entrepreneurs bringing these new products to the markets. And those are the ones sometimes that are not following the the guidelines and more likely fall to the cracks. And but still, the products are reaching those informal markets and people are buying. So what are those innovations? And the word innovation here is very widely used in, could be as simple as packaging or labeling. So what do you think about that? What are kind of innovations for those small and medium-sized companies?
Absolutely a great question, and you're right. Especially the use of the word innovation is really interesting, especially from when we think about it from the food safety side. We're not a physical lab. We really are trying to drive food safety through research. And if we're thinking more along the technology standpoint, or if we're using that lens, in my opinion is that we need fast and really cost-effective and low input pathogen detection platforms. And I mean, everyone in there, tons of people are chasing that dream, certainly. But really achieving that is probably one of the hardest things we're running up against in general. Because if that could have been done easily, it would have been done. But allowing or providing a tool or a choice of tools to smaller companies to help them make kind of binary go, no go type of decisions on whether a product is safe could be really influential, and something that's easy to interpret and doesn't take a whole fleet of technical experts to understand or support the equipment. All of these come together, and again, that unicorn of a platform. But if we can understand where the pathogens are, and if we can understand what the true baseline of foodborne diseases in a country, that's when we can actually start to measure change.
Excellent. Thank you for that answer. Now we're going to continue with our next speaker. Welcome again. Now we're going to have our third and last speaker. I have with me Professor Dr. Sarah de Saeger. She received her MS and doctorate degrees in pharmaceutical sciences from Ghent University. She's currently a full professor in the Faculty of Pharmaceutical Sciences at Ghent University, where she directs the Center of Excellence in Mycotoxicology and Public Health. She's also coordinator of MYTOX and MYTOX-SOUTH, a member of Food to Know and CropFit. She's a member of the Ghent University, Shanghai Jiao Tong University, Chinese Academy of Sciences, Joint Laboratory on Mycotoxin Research. I would like to point out that and something that I thought it was very interesting, and she will talk about this today, is about MYTOX-SOUTH. This is a team intends to harness the expertise of infrastructure available at Ghent University to strengthen the capacity of the Southern partners to tackle the mycotoxin problem and the associated food safety and food security issues. The MYTOX-SOUTH is a partnership to improve food security and food safety through mitigation of mycotoxins at the global scale. This well-structured multidisciplinary partnership, which deals with all known aspects of mycotoxins and toxigenic mold issues, is able to provide the most adequate strategies and solutions for different stakeholders. And I think it's something that our attendants from Sub-Saharan Africa wants to hear. Thank you, Professor Saeger. Her title of presentations is Mycotoxins, an Important Food Safety Issue. The floor is yours, Professor. Thank you.
Good morning, everybody. So I'm very happy that I can be part of this very important conference. So greetings from Belgium, and today indeed I will talk about mycotoxins. The content of my presentation, I will briefly go into food security, food safety, and it was very nice to have the presentation by Professor Oliver just before mine, which will make my job a little bit more easy for this introduction. After that, I will mainly talk about mycotoxins and their relevance in the soybean chain. And at the final part of my presentation, I will talk about challenges in Sub-Saharan Africa and the MYTOX-SOUTH partnership. So first of all, it was already said that, in fact, unsafe food is no food. So, and this is clearly stated also in the definition of food security by the World Summit, and also in the Sustainable Development Goal number 2, that in fact, all people need to have access not only to sufficient food, but also to safe food. So in this respect, I also would like to highlight the World Food Safety Day, which was organized this year by the World Health Organization, which also clearly said that it's important that we team up for safety, as food safety is a shared responsibility. And indeed, food safety is under pressure because we have, of course, also the population growth, and we have climate change and global warming, which make it more difficult to obtain the Sustainable Development Goals. If we have a closer look to food safety risks, so Professor Oliver just showed that microbiological contaminations are really very important and mainly concerning acute health risks. But if we look to the chronic health risks, so for long-time exposure, then mycotoxins are on top of the risks. So in fact, what are mycotoxins? Those are not new. So mycotoxins already do exist since mankind started to grow crops. And in fact, the first reports that we can find is not written reports, but for instance, through paintings like this one from Peter Bruegel, in which you can clearly see some people with missing limbs. Now, this was due to a disease called Holy Fire or St. Anthony's Fire, which was, for instance, reported in France in the Middle Ages, and which is caused by fungi, which are called Claviceps purpurea. On the slide on top, you can clearly see a black body in this cereals, and this black body contains a lot of what is called ergot alkaloids, which are in fact mycotoxins that cause gangrene of limbs and also hallucinations. But research on mycotoxins only started in the 1960s after a great outbreak where 100,000 of poultry birds died in the United Kingdom after getting groundnut meal feed, which was imported from Brazil and which was containing a lot of mycotoxins. So these were in fact the first mycotoxins that were identified, and those ones were called aflatoxins, the ones that Professor Oliver already discussed. So having said this, a little bit more theory behind the mycotoxins. So those are fungal secondary metabolites. So this means that in contrary to the primary metabolism, these mycotoxins are not directly essential for growth of the fungi. In fact, what they are doing is they play a very important role in the defense mechanisms of the fungi, mainly when they are under stress conditions. For instance, if there are other invaders or competitors nearby. So why are those then important for us, for humans, and also for animals? Because they cause adverse effects. And as you can see on this slide, there are many different, very structurally diverse molecules, which are those mycotoxins. And because of that, they also have many different toxicological effects. So some of them, for instance, have an influence on our immune system. Others have neurological disorders, and some of them are carcinogenic or cause growth retardation. Also very important to tell you from the beginning of my presentation is that those chemicals, so those natural chemicals, are very stable. So they are generally conserved during storage, during processing and cooking. So this in contrary to, for instance, microbes, which can be killed through a heating process. So here, this is not the case. But of course, everything about toxicology is related to the quantitative aspect. So it's about, as this father of toxicology, Paracelsus, said, it's only the dose that makes the poison. So this is the same for mycotoxins. But here I would like to make a difference between indeed the acute poisoning through a short-term and high exposure, which for instance is possible for aflatoxin B1, which is then deadly through liver toxicity. And we call this acute poisoning aflatoxicosis. But on the other hand, there is also the chronic toxic effects through a long-term lower exposure. And in this case, as I said in the beginning, mycotoxins are really on top of the risks for chronic health problems. And one of the examples is again for aflatoxin B1, it can also be a liver carcinogen. So, and then here on this slide, I just show you some of the most important and also regulated mycotoxins, but there are many more. So this is just a brief list with on top aflatoxins, which I already discussed, followed by fumonisins, which are mainly targeting the use of phages, zearalenone, which has a completely different toxic effect. It's causing hyperestrogenism, ochratoxin A, which targets the kidney, deoxynivalenol, which causes gut inflammation and increases the risk on colorectal cancer, T2 toxin, which suppresses our immune system, and ergot alkaloids, which I already discussed, are causing gangrene and hallucinations. So, in a nutshell, mycotoxins are food contaminants, and we find them in all kinds of crops, fruits, nuts, and also, but this is just a very side comment of this presentation, they can also be present indoor if there are, for instance, fungi growing on a wallpaper or in the bathroom. Then about the situation today. Research started in the 1960s, but unfortunately, mycotoxins are still present. And one of the major problems we find in indeed Sub-Saharan Africa. So these are just some examples of newspapers. For instance, this one is about an acute aflatoxicosis outbreak in Tanzania, which was due to aflatoxin contamination in corn. And then also in Kenya last year in 2019, there was a huge problem with the maize or corn flour. A lot of corn had to be withdrawn from the markets because of aflatoxin contaminations. Also, this report is very interesting from IARC on cancer in Sub-Saharan Africa. And also there, it's clear that there is this relationship between liver cancer and aflatoxins. And last but not least, a lot of research is currently ongoing on the relationship between mycotoxins and stunting or retarded growth. But I also would like to highlight that in many different African countries, there are still a lot of unreported cases and unknown occurrence data. So we don't know very well how the situation is in different parts of the world. This brings me now to the soybean. So first of all, it was already clear from what I said that corn is one of those crops that is majorly contaminated. It's one of the most huge problems concerning mycotoxins in Africa. but there are also other crops. And I will just first start to show you some results of analysis that were done in our lab by mainly PhD students from Africa, and here one from Pakistan, but all the others are African. And you can see that maize, sorghum, millet, in all those crops, we could find many different mycotoxins and also quite high occurrence rates. But so these are just the crops, but then the processed foods like fermented food, beers, cassava, yam products, also there we still have mycotoxins because, as I said, they are very stable. And also here, a lot of different mycotoxins that co-occur and high percentages of occurrence. Now the soybean. In fact, there is not too much research done on soybean if you compare to maize or corn. So in my lab, in fact, we have done 2 studies on soybean, and I would like to share this information. But generally spoken, it is clear that soybean is less susceptible to mycotoxins than, for instance, corn. But let me show you the results. So this first study published in 2018 was about soybean in Rwanda. As you can see, it's a collaboration with Jagger Harvey, who is also a director in one of the Feed the Future Innovation Labs. I think it's Kansas University. So in this collaboration, the PhD student from Rwanda, Margaret Niyobuteronsa, she had sampled 300 soybean samples, different moments, I mean also pre and post harvest, different drying days, different storage. And in fact, the general result was that almost none of them were contaminated with mycotoxins, which is, of course, a very good news. So you can see that only one was really positive above the maximum limit. So this was for aflatoxin, but we also analyzed other mycotoxins, and beside one mycotoxin, stereomatocystin, we didn't find any other mycotoxin. So this was really great news concerning food safety of soybean. But we also did a study in Nigeria, and yes, of course, it's also important to tell you the study in Rwanda was just done in 1 year, 1 season. So of course, the fungal development can also be different according to the year and season. Concerning the next study, which was done in Nigeria, this was also done by a Nigerian PhD student in my lab. And here we didn't look to the aflatoxins, but we wanted to have a closer look to other mycotoxins, more specifically Fusarium mycotoxins. And here she did a lot of work in different crops, but also in soybean. So this slide shows the natural occurrence of Fusarium mycotoxins in soybeans and soybean powder. And first of all, what was clear is that we found a lot of different Fusarium mycotoxins in the soybean. And if we have a closer look, the most frequently occurring was this one, which is zearalenone, which is the one that causes the hyperestrogenism. So it has estrogenic effects. So what was also striking was that in the soybean powder, so after the processing, we had a higher number of positive samples than the fresh soybean. And you can also see that the concentrations were quite high and above the European limits of legal limits. So why is the soybean powder more contaminated than the fresh soybean? We believe that this is indeed the result of, for instance, poor storage or poor food packaging. So those things, storage and packaging, are really very important. And I think this is a very important message I also would like to give to the soybean processors. What she also did was to check the influence of processing. She started from soybean and then used two types of processing, one with roasting, the other with soaking. And the first one resulted in a roasted soybean powder, and the second one in a blanched soybean powder. So the soybean powder is mainly used for infant foods in Nigeria. So, and that's also important then, of course, to have very safe food with very low amounts of mycotoxins. So she was evaluating if these mycotoxins, again, Fusarium mycotoxins, at certain concentrations could be reduced during this processing. And here you can see the result, and I will just, because of time, I will concentrate on one concentration, the highest, 1,000 microgram per kilogram spike concentration. And this is the first processing with the roasting. You can see that indeed roasting reduced a lot of some of the mycotoxins. However, for zearalenone, it was not the case. You can only see a 20% reduction after the roasting. But then the second part, the dehulling and milling, is really very important, as you can see, because after dehulling, the reduction was really great. This is because mycotoxins and the fungi that produce the mycotoxins are mainly present at the outer parts of the crops. For the second one, the soaking and blanching, again, you can see that soaking did not really give a great reduction, although there was something. But again, blanching and dehulling then could result in a greater reduction. However, you can see that none of those steps resulted in completely mycotoxin-free products. So also in this slide, which is very full, I know I just want to show you this. Here you can see the original spiked concentrations, and in red, you can see what is remaining after the processing. And although it's a quite huge reduction, there is still mycotoxin present here also in the soybean, the blanched soybean powder. So that's another thing I would like to tell you. Please start with materials when you start the processing. Don't think that you can get rid of all the mycotoxins just by processing, but start with starting material, which is already fine for concerning mycotoxin contamination. And yeah, so this slide here, I would like to show you the huge challenges. I mean, to look to mycotoxin contamination, it's very important that we start from the beginning with prevention. Everything starts with location, cultivar, crop rotation, of course, climate, which we cannot change ourselves, but also use of fungicides, fertilizer. All of this has an influence on the ecology and biology of the fungi and at the end, the mycotoxin production. So everything starts with good agricultural practices, but then also during harvest, it's important to evaluate moisture and temperature at harvest, and for post-harvest to use good drying measures as well as a good storage management system, because mycotoxins and fungi can further develop during the storage. And here, just very briefly, I would like to show you this slide, which is about a project which is just finished in October this year. It was the EU-funded MycoKey project, which was coordinated by ISPA CNR in Italy. And here I just would like to show you this, that indeed every step of the chain, of the food chain, and also of the soybean chain is important in the mycotoxin risk assessment and mycotoxin reduction. As Professor Oliver said, of course, it's also very important to be able to measure those mycotoxins at the different critical points with fast and easy to use detection tests. So this brings me to the last part of my presentation. I will first give you a list of challenges in Sub-Saharan Africa and more broader in low and middle income countries. I've put all of them on one slide. However, I could talk about this for more than 1 hour, but just briefly, of course, weather conditions, lack of awareness, poor agricultural practices, poor storage, all those favor mycotoxin production. So maize or corn and groundnuts, in fact, are the major staple food crops that are prone to mycotoxins, but also other cereals and other crops and fruits can be contaminated with mycotoxins. Mycotoxin control is till now mainly focused on aflatoxins in Sub-Saharan Africa, while the other mycotoxins should not be forgotten. That is something that we showed in the work from the Nigerian Ph.D. student about the Fusarium mycotoxins. Generally speaking, there is still a big lack in analytical capacity. Implementation of legislation is often lacking. And one of the key solutions that is now being advertised more and more, but of course it's not so easy to realize, is to have a bigger dietary diversity for the people, so that they are not eating all day round corn or groundnuts. So this can be done by introducing other crops and also indigenous local crops. Now, because of all those challenges, in 2017, I decided together with my team to start this MYTOX-SOUTH network, because global problems need international approach. And here you can see at the moment the different regions that we now cover and where we have collaborations. And you can see it's around the globe. So also in USA, China, Russia, and many low and middle income countries with, at the moment, a major focus on Sub-Saharan Africa. So what is the aim of MYTOX-SOUTH? We educate and train young students and scientists in our labs. So we are building capacity through co-creation. We organize a lot of awareness creation seminars, like this one here at the left of the slide. This was the last activity that we could do before COVID lockdowns. So this was in South Africa, Johannesburg, Soweto, where we had a farmers lab, so an awareness creation, awareness seminar on mycotoxins for farmers in Soweto, which is one of the biggest townships in South Africa. And next to that, of course, we also are conducting a lot of research, and we are developing innovative technologies. Now, what I would like to do now is to show you a short movie, which 3 minutes, and after that I will come back.
Did you know that one of the greatest threats to global food safety originates from a natural source? Mycotoxins, which are poisons produced by fungi, cause cancer, suppress the immune system, and retard growth. The majority of the world's food crops are contaminated by these highly toxic substances. Cereals, bakery products, nuts, fruit, herbs and spices, cocoa, milk, coffee, tea, wine, beer, they are all predominantly contaminated. The incidence is therefore a danger to human health and an important source of food waste. The most affected crops are those being produced in low and middle income countries. To make matters worse, poverty, population growth and climate change further challenge food safety in these regions. In 2016, During a severe mycotoxin outbreak, vast numbers of Tanzanian children and elderly people died from consuming homegrown maize, containing mycotoxin levels up to 1,000-fold of the EU maximum level. Furthermore, mycotoxins have profound economic impacts, depriving low and middle-income countries from trading with the rest of the world. To illustrate, the European Rapid Alert System reports mycotoxins as the greatest hazard originating from non-EU countries. Although easy and effective intervention strategies do exist, affected countries still lack awareness and have limited capacity to implement legislation, prevention, and monitoring systems. Mycotoxin mitigation therefore requires an international approach, and this is where MYTOX-SOUTH offers an integrated solution. The MYTOX-SOUTH Global Network builds sustainable, equitable partnerships and develops human capacity. Our organization bridges the gap between academic research and industry by mentoring and training researchers and QC personnel, consequently enabling co-creation of mycotoxin reduction measures fit for local use. We offer our unique 25 years of academic experience in food safety research to build global mycotoxin awareness, from farmers to industry to policymakers. Join us. MYTOX-SOUTH is your international partner to achieve your food safety goals.
All right, I hope you all liked the video, and so I just would like to end my presentation with some take-home messages. So yes, now you know that mycotoxins are produced by fungi in food and feed. They are in fact unavoidable, although prevention measures are very important to reduce the levels, but they are also very stable. They cause different health effects in human and animals, and we know that they are present in more than 60% of the global food crops. Also, climate change is further worsening the problem. And last but not least, yes, food safety is a very important part of food security. So let's team up and work together to guarantee more safe food for everybody. Thank you very much for listening.
Well, thank you very much, Professor Saeger, for this interesting presentation on mycotoxins. I can say that I didn't know enough of it, and now I feel that I can understand more about what we can do to address it, especially from the point of view that the life in the tropics is harsh already with the conditions, perfect conditions for aflatoxin or mycotoxin growth. So we're gonna ask you one question, and then we're gonna break to start our panel presentation discussion. So the question is about the processing, and because it was very interesting results you found, and I was wondering how these aflatoxins, how these studies were designed. Do you have inoculation, or it was just let it happen within the conditions of present in this case? I think it was Rwanda, if maybe I'm mistaken.
Yeah, so no, the test on the food processing, on the soybean processing, was just done in the lab, small scale. where we have spiked the soybean with mycotoxins. So it was not first a fungal growth and then have the mycotoxins developed by the fungi. No, this was directly spiked mycotoxins on the soybean. Why did we do it like that? Because of course it's technically spoken the most practical way. Because if you grow fungi, you never know what they will do, because those are very sometimes they are really not doing what you would like them to do, and sometimes they produce too much. So for this reason, it's the most controlled way to just spike the mycotoxin. But on the other hand, we also know that this is not the natural way, and it's even possible that when the fungi produce the mycotoxins, that some of the mycotoxins, for instance, are hidden or masked by binding to proteins or some things like that. So we know that this design is just a first design to have a look on what exactly happens with the mycotoxin.
Excellent, thank you. And now we're going to pause and we're going to bring all the speakers for our final panel discussion. Well, welcome back. Now we have our three illustrious speakers. What we're going to do is go over some of the questions from the audience, and some of the questions will be directed to the speakers, and some more will be to anybody who wants to answer them. And at the end, we're going to give them about 30 seconds to bring their final remarks, final words of wisdom, so to speak. So let's start first with Professor Chen. So one of the questions, and it's something that, of course, you're going to realize this is something that's going to come, and the question earlier about the products reaching the markets. Is these materials, these plastic materials that you can make from these biomaterials, is this expensive to create?
Okay. This is a very good question. So at the lab scale, nothing is too expensive. Otherwise, there's no scalability. In terms of our industry engagement, we have done the life cycle assessment, right? And it turns out to be far more expensive than the petrochemical derived clean film. Yeah, that all depends also on the quantity eventually. So demand drives supply, but this is certainly a viable option. Yeah. Here we are talking about various sources of clean film. So that can include from soybean residue, can be from the brewer's spent green, as well as shrimp shells that I mentioned at last presentation. In addition to that, one of the even cheaper way is to produce secondary packaging, not a full. I mean, it's not a clean film, but rather biodegradable secondary packaging, like a container for the lunchbox, this kind of thing. Yeah, that would be even cheaper. Yeah.
Thank you very much. And that's because listening to Professor Oliver and Saeger about food safety and mycotoxins, one of the technologies that is revolutionary is this PICS bags technologies developed at Purdue, and I'm very familiar with the history of these and the fact that it's being used everywhere now in Sub-Saharan Africa for storage of grains, which has reduced contamination. And I wonder if these type of packaging technologies that you develop, Professor Chen, can be used to store grains and in a way that is, because that's another problem these PICS bags have, is that they will go bad after a few cycles of use. And that will become a problem, of course, in these places where you have to dispose plastic. So I wonder if this is something that your type of technologies and with biomaterials could be something that enhance the value of these PICS bags in Africa.
Very interesting question. I would say at this point in time, probably there's still some way to go. There's probably still some way to go in terms of this harsh condition of, once you package these beans, you need to not just store them, but also transport them to the processing side and consumer retail end. All this may not be a optimum condition to use the biodegradable packaging, because as Professor De Saeger mentioned, there are a lot of bugs in if they produce mycotoxin, that means there are microbes inside. So I'm worried that halfway through the transportation, then the bag may disappear. So I would say probably at the consumer retail end, this may be more have higher appeal and value rather than this packing bags. Yeah.
Thank you for that answer. I thought so too. It's an interesting conundrum, but I guess we get more heads over this as Professor Laborde mentioned. It's innovation. It's there for us to take it, I guess. So a question for Professor Oliver from the audience, and this is a hard question to answer, but I'll let you do your trick here. So what is the most important quality control for processors regarding food safety? And you can answer it from any processing. Let's go with agro processors of cereals. It's just easier. I don't know.
Yeah, no, that's a great question. And I think if we had 2 or 3 days, we might get the short list of what that really is. I think it comes back to prevention is key. That a lot of these safety risks, whether it's on the mycotoxin chemical side or biological side, some of these things cannot be processed away. And so in primary production and knowing that if inputs into maybe a cereal processor, knowing that the inputs coming in are safe is really the best safeguard to producing a safe end product. And that's not an easy thing. It's like innovation, it's not an easy thing. But increasing awareness and understanding of how to prevent, especially outgrowth of the fungus that can produce the mycotoxins is key. And that really is going to come probably back to moisture control. And so you put your contaminated soybeans that are not sufficiently dried into a PICS bag, you might stop insect growth, but you're going to create an amazing microbial growth opportunity. So really making sure that those early in the process ingredients are high quality and safe is really the best strategy.
Well, thank you for that answer. I'm gonna go and now ask a question for Professor Saeger. Can processed foods be cross-contaminated with aflatoxin mycotoxins from processing machines, processing equipment at any level?
Okay, thank you for this question. This is not an easy question. Of course, everything depends on indeed cleaning your machines in between and decontaminating them, which is of course possible. I mean, you can clean or you can get rid of aflatoxins by using different chemicals But yeah, of course, then you have to be sure that also those chemicals are not anymore on your machines. So this is indeed a very important question. It's still possible that also some molds are still present, yeah, due to not working with clean environment. So hygiene is very, very important for all aspects of food safety, but also for mycotoxin reduction. Yes.
Thank you for that answer. I guess it's a follow-up question to that, because all of you probably are understand this quite well, is that we cannot diagnose, we cannot treat what we cannot diagnose, I guess is the best way to put it. And that requires good tools and good instruments. And the more I travel, to me, it seems that it has to be, as Professor Edward put it, has to be accessible and easy to use and easy to implement changes. And I think it's the same for not just biological hazards, but all chemical hazards as well as physical hazards. So is there and this is a question for the audience, for Professor Saeger, is there any economical way processors can test for mycotoxins during intake of commodities and processing?
Yeah, thank you. This is also a very important question. There are rapid tests available on the market. For instance, for a very quick control of, let's say, aflatoxins. It's a dipstick type of test, as you have, for instance, pregnancy type of test. So it's this simple and easy to use, but yeah, it's a screening test. So you will just know if it is above or below a certain cutoff value. So those are available, and some of them also make use of smartphone technology so that you can easily have your results immediately on the smartphone. But nonetheless, I think they're still quite expensive to use very frequently. It depends on if you have a very huge company or if you are just a smallholder farmer. So for a category of smaller companies, this might be still not affordable. So, but I know there are still a lot of projects ongoing to have more affordable of those very easy and simple test kits.
Thank you for that answer. Professor Oliver, what do you have a sense of how much biological contamination is coming from the water added to the household level, this burden of disease?
Oh, that's a great question, and it has a lot of answers because it's very situation dependent. I mean, one example I can speak to, research that our group did in Afghanistan was, 33, anywhere from 25 to 33% of water sources were contaminated with coliforms, which would be a fecal contamination indicator. And that was both well water and municipal water. And when we're talking about municipal, that means that that's reaching a lot of people. And so is it a significant source of contamination? Absolutely. And water is, it's just so foundational to survival anyway, but it's a big part of food production and food processing, and becomes an ingredient. And so, we think about it as just as an important ingredient from an ingredient standpoint to be safe. You also can't improve sanitation of your equipment, whether you're trying to remove mycotoxins or other bacteria, if your water itself is contaminated. And so that too is no simple fix, whether it's deeper wells, different sources, making sure that waste and potable water are really distant space are, again, big components of driving this, but also big infrastructure investments.
Thank you for that answer. So one more question for Professor Oliver from the audience. And again, these are hard questions, and I don't know if there is easy answers, honestly, but here you go. How do small producers keep food safe without ice or refrigeration? I guess it depends on the type of industry, but I told you it's hard.
That is a very great question. And this is like a PhD defense. Every once in a while you have to be put through your paces to answer the tough questions. Yeah, it's very commodity specific, but that is one of the largest challenges, both from a safety and from a food loss, quality, and waste, is cold chain and refrigeration. If we're talking about produce, that doesn't have an easy answer, especially if it's leafy greens. You know, trying to keep it cool, trying to keep it hydrated if you don't have a cold source is fundamentally right up there next to the impossible if it's cut, if it's actually been cut at the plant base. But it would motivate me to think about, I guess, a different crop that could be a little more tolerant of dehydration, of not needing cold chain. And of course, that doesn't necessarily align with consumer preferences or what they're interested in purchasing. So no, it's a big part of the long game investment for improving food safety and food security is finding economical, as again, cold chain is very energy dependent. It's going to take a lot of infrastructure investment. Again, how do we find practical solutions to that? And what kind of investment will it be? Remains a big question. So I answered a question with a question. I did that.
I think we all have done that before. Thank you. One more question for Professor Chen. So you live in a very small country, right? And you see the challenges that you have in Singapore are all there. And it's about getting the population thinking in the right direction, I guess, and talking about these pull-push strategies to bring these technologies or bring these changes, and sometimes some of which are behavioral. How do you see that the government of Singapore addressing food insecurity? Giving some examples of how, for example, the government has led to bring food safety or nutritious quality foods to the masses, to the point that you have now food waste, right? So could you elaborate on that?
Well, that's a great question. So I'm very happy to be among the panelists who are the expert in food safety. And as I entirely agree with the assessment, no food safety, no food security, right? No point eating the food, everybody gets sick. So that defeats the purpose. So to answer the question, Singapore government has established this new framework called Singapore Food Story. So under which there are three pillars. One is urban farming. So this is to push up local production capabilities to mitigate the disruption due to supply chain disruption. That can be COVID-19, can be other infectious disease or pandemic in the future, which bound to happen. The second one is novel proteins. So we talk about, because Singapore we don't have animal farms, so we import all the food, including meat, from overseas. The question here is how can we beef up meat proteins production level? Of course, we will not free up land to allow cattle farm or a pig farm. That's beyond the point. But Singapore is surrounded by seas, so aquaculture is one of the ways to push up protein supply. But we're also looking for alternative protein sources that may include the protein-rich microalgae or insect protein. So recently, Singapore became the first country to have approved culture meat from the lab. There is actually the American company called Just. Just Incorporation was famous for the making the egg without chicken, right? So now they're making the chicken meat without chicken altogether. So this is approved in Singapore. Why Singapore has become the first country to approve this? There's a lot of reason for that. First, we do not have we don't have animal farm, so it's a lot easier to worry less about job displacement for farmers. And also, this is part of the technology-driven production scheme. So, and that is a story about the alternative protein sources. The third one is actually related to food safety, science, and innovation. So under the food safety, Singapore food story, there are three pillars. My university is the host for the food safety, science, and innovation. So I hope to have a lot of interaction with Professor Oliver and Professor De Saga. With Professor De Saga, even better because I study in Belgium, although in French. So there's a lot of connection here and there. So I hope to have interaction with panelists. But to answer the question, so there is a framework to not just to beef up primary production and look for alternative food source, but also improve food safety risk assessment of all these novel food, and also along the way improve, increase the awareness of consumers towards novel food. Because if there's no consumers buy-in, no matter what we do, it will be a zero-sum game because no one buys it. So this is how we, as government-driven approach to enhance the food security in Singapore. But we also work with the food industry to sort of incorporate our innovation in the processes so that to have a better, new ways of producing food and a more efficient way of producing the existing food. Yeah. So this is my 2 cents of assessment of the situation in Singapore. I just want to add one line is that Singapore is so small. I don't know how many times you read news about Singapore, maybe once every 10 years, but so that's to say that no matter how high tech we can go, the impact is not felt. So we are hoping that with the global trend of people moving to the urban area to live in, there will be more and more urban farming appreciation. So the idea here is that we hope to propagate our urban food system to the region, and so to create a real impact. And then first we start with ASEAN, and then maybe later on beyond ASEAN. So only then we will see that everybody benefit from this efficient food system, and then we grow together in terms of enhancing food security. Yeah. Sorry, I talked too much. Yeah.
Oh, Professor Chen, this is great. This is wonderful. I think everything starts with good foods and safe ones, and
Yep.
Understanding our needs, and from there we go. I think I have one more question for Professor Saeger that just came in about extrusion technologies. Would extrusion technologies, which uses heating to create these interesting consistency type products such as snacks and why not, would these type of processing kill or reduce aflatoxin or mycotoxin contamination in a food product?
Yeah, I know there has been a lot of research on extrusion. It's not completely my field, but I know in the US there are some groups working on that. And I thought it was mainly on the fumonisins that they did this work. And indeed, as most of the processing techniques, there is some reduction. But also here, I don't think it's a complete reduction. But I cannot say much more about this, but there is for sure a lot of research done on this.
Excellent. Thank you, Professor Saeger. So now we have reached the end of our panel. I would like to offer you 30 seconds to tell us some words of wisdom. And we'll start with Professor Chen, then Professor Oliver, and then Professor De Saeger about I think the world has seen tremendous pain, I would say, in this year, and frustration, but also have seen tremendous hope. And I think there is hope in technology, and there is hope of understanding, and hope in science. And I want to stress that. So I wonder if you can, in 30 seconds, tell us how do you see the world is going to be in 2021, where you should think we should focus our attention in your respective areas of focus, of course. But where do you think this technology should go to help us? Go ahead.
Ladies first. I will speak the last for once. Yeah.
Professor Oliver, go ahead.
No, you're right, Juan. It's while a challenging year, there's still been some impressive things that happened, and I think just looking at the possibilities of the vaccines and the timing and the amount of the speed at which they were developed is a real testament to science. And what I hope is we can keep that positive attitude to really make our best effort to make sure that the investments in food security aren't reversed. And we know that there have been significant setbacks because of COVID-19. But how can we come together and be our best to prevent collateral damage in that space is huge. Food safety, of course, is a part of that discussion, but there's a lot of big picture, big challenges that come together to make sure that the world doesn't have a massive setback as a result.
Thank you. Professor Saeger.
Yeah, thank you for this question. And yeah, it's very nice to give messages of hope. And every negative thing like this year has also some positive results. And one of the things which are indeed very important concerning food safety, not only mycotoxins, but in general, is awareness creation. And I think due to this, let's say, the fact that we are now all using Zoom and all those kinds of digital platforms to talk to each other, might even create awareness for much bigger publics who before could not afford to come over to a conference somewhere in a part in the world. So yeah, I think everything starts with awareness creation. If we know that, then the technology can help us for prevention, reduction, mitigation, and so on of all the problems regarding food safety.
Thank you. Professor Chen.
Right. I would say that we can look for improvement in efficiency of the food system. This is very amazing when you look at the single cell in mammalian cell, bacterial cell. Very little waste, right? So we recycle the building blocks from nucleic acid to amino acid. We recycle them. Well, so when we talk about food system, there's so much wastage. So this crisis would be a good time to turn things around, to improve the efficiency of the food system, so that we don't everything go one-sided, either push for GM crop to push for the production, or now is everything's land meat. So we should actually go for efficiency, reduce waste, and create this alternative solution as options. Only then we would sort of improve the overall food system and then achieve this food security, not within just one country, but around the world. Yeah, this is what I hope to see. Yeah.
Well, thank you very much. I just want to say a few words to thank the panel, Professor De Saeger, Professor Oliver, Professor Chen. You've been grateful for with your times, and we appreciate bringing these words of wisdom and hope to our attendants. Again, we will do one more day of this symposium tomorrow at the same time. Be ready for those very wonderful presentations. Today, I just want to say thank you to the AOCS, the Soybean Innovation Lab, and IFT, and these other organizations that help us bring these speakers together and bring you great information for your companies. With that, thank you very much and stay safe.
Thank you.